This question is about a titration. A student dissolves an unknown mass of sodium hydroxide in water to make 200 centimetres cubed of aqueous solution. So the first thing to point out is that 200 is not the normal amount that we would make in our volumetric flask. So just to be aware, we're not looking at 250 here. 25 of this sodium hydroxide was placed in a conical flask and it is titrated with sulfuric acid. So here's the sulfuric acid, here's the sodium hydroxide. We've got the concentration of the sulfuric acid, but we will need to find the volume, and we're going to get that from the titration results. We're going to need to find the mean titer. So we're looking for two values that are concordant within 0.1. Little tip is it's pretty much usually going to always be the last one because we kept going until we got concordant. So then we need to go back and find one within 0.1 of that. So we're going to find our mean titer by averaging the two concordant results. And that is the volume of sulfuric acid. So then we can find the moles of sulfuric acid. Remembering to turn that volume into decimeters cubed and then times it by the concentration. Type that into our calculator. We get 2.936 times 10 to the minus 3. Then if we use the ratio from the balanced equation, we can find the number of moles of sodium hydroxide, and the ratio is 1 to 2. So we're going to do 2 times 2.936 times 10 to the minus 3, which is 5.87 times 10 to the minus 3. That's in 25 in the titration. So how many were in the flask? And remember that the flask was not 250, it was 200. So there are not 10 25s, there are only 8 25s in 200. If you do 200 divided by 25, you'll see that that is 8. So we're scaling up by a factor of 8. Oops. And then we're going to find the mass is Mr. Moles. So the MR of sodium hydroxide is 40. And that gives us 1.88 grams. The student uses a funnel to fill the burette with sulfuric acid before starting the titration. After filling, the student forgets to remove the funnel from the top of the burette. Suggests why this might affect the titer volumes. Well, what might happen is, so just remember that you've got your burette here, and if you've left the funnel in and the funnel was used to fill, then drops of sulfuric acid from the funnel can enter the burette during the titration What this actually does is make the value on the burette lower, because you think, oh, I'm adding liquid, it will make it bigger, but you're adding liquid to what's left. Remember, with a burette, you measure what you've used, and so if there's more left, it will assume that there's less used. State one advantage of using a conical flask rather than a beaker during a titration. Well, a conical flask, you need to swirl during a titration, and a conical flask prevents loss through splashing, so losing the solution when you swirl. So we've got less chance of loss through splashing during swirling.